Hello, my name is Imran Aslam. Today I am going to give a demonstration on an application called Total Dynamic Head of the Pump. First of all, I will explain the installation procedure of the application through a setup file, and later I will explain the main features of the application. So let's start with the application installation procedure. So if you already have downloaded the setup file from my website www.petrosoft.com, then you can simply double click on this application setup file. The application wizard will be launched, or the application utility will be launched on your screen. From the language section, you can select the appropriate language and press the OK button. It will take you to the license agreement page where you can select an appropriate option and press the next button. Then it will take you to the information page. Again, press the next button, and then it will take you to the option page where you can create or specify to create a desktop shortcut of this application. So it is always good to create a desktop shortcut of the application so that you can launch the application on your computer straight away from your desktop shortcut anytime in future. So I will check this create desktop shortcut option here and press the next button. It will take you to the final step of the installation, where by pressing the install button will simply install the application on your computer within few seconds. Since I already have installed this application on my computer, so I will just simply cancel out this utility and go to my desktop where I already have saved the desktop shortcut of this application earlier during the installation. So I will simply double click on this desktop shortcut. The application will be launched on my screen instantly. Now first of all, let's look at the top menu bar. On the left hand side, the first menu bar, on the menu bar, the first tab is the file tab. Under the file tab you have the three new tabs. The first tab is a new tab, the second is the save tab, and the third one is an exit tab. So for example, if I close this application, and I can create or I can start the new instance of the application by simply pressing the new tab option over here. The new application instance will be launched. The second option is the save button, which can save the results of the application into the PDF file format. The next option is the exit, to close the application. The next main option on the menu bar is the about option. You can review the information about the application and the developer by pressing this about tab. The third option is the help menu tab. When you press the help menu tab, the application manual will be launched in the PDF file on your computer. This application manual comes along with the setup file, where you can read in detail with the pictorial representation of all the details about each step, and the sections explained with the pictures and the complete description. So moving back to the main application. The main function of this application is to calculate accurately the total dynamic head of the pump. So in your facility, you may have already an existing pump with the suction pipe and the discharge piping operating at a certain fluid and pumping the fluid from one destination to the second destination. So in that system, anytime in the future there comes an option where you like to modify the suction piping of the system or the discharge piping of the system, or simply you wanted to change the fluid service of the system, or the destination equipment or a destination final pressure changes as per your process requirement. So in all these circumstances, this application can be used or utilized to estimate the new total dynamic head of the pump, to estimate or to determine whether under the new circumstances or the new conditions, or after modifying the existing system, whether your pump or existing pump will still be capable of delivering the required head adequately, or you need any further changes in the system. The second condition is where this application can be helpful is to design a new piping system for the client. where the user need to specify a complete set of suction piping system and the discharge piping system, including all the fittings and piping components in the system with a brand new pump. So where you can utilize this application to estimate what is the total dynamic head required for the new system for which you are going to design the new pump. So in all these circumstances, this application is very useful. To calculate the total dynamic head can be very tricky sometimes, because you may have to include all the head losses of the system, including the pipe fitting losses, elevation losses, destination pressure losses. All this information required to be calculated separately in order to compile the result into one single total dynamic head requirements. So this application can be useful in that condition where you have multiple different utilities or multiple different sections of the system where you need to define or calculate the head losses. So all the head losses of the entire system can be developed and calculated in under one utility, under one application. So that's where this application is very useful. So let's start with the working of this application, or the main features of this application. This application basically has four pages or four tabs at the top below the menu bar. As you can see, I pressed each of the menu bar and it is showing or displaying on the screen. So let's start with a new instance of the application, where the application is completely blank, and the user first of all start to provide the inputs, and then later the results will be calculated. So basically in the pumping system you will have two set of piping system. One goes at the suction of the pump and the other goes at the discharge of the pump. So here in this application you can define the complete piping system or piping components at the isometric level, which means that you can define each and every component of the pipe, including the isometrics, including the elevation differences and all the fittings that are going to be attached on the piping system for both the pipes at the suction and as well as at the discharge. So that is why two separate pages of the pipe hydraulics have been given in this application. The very first page deals with the pipe 1 hydraulic, which means that this is the first set of piping system where you can select whether this pipe will be installed at the suction of the pipe or the discharge of the pipe. So the very first input that the user need to select or provide here is in the piping data section at the top, where the pipe 1 location is defined, where the user can select either one of the option, the pump suction or the pump discharge. So by selecting this option, user can define that the first set of piping system will actually goes or install at what location. So here I will select the pipe 1 location to be at the pump section. So once I select this option, the option will be selected with the, and it will be highlighted at the same time with the yellow color, as you can see on the screen. In the same piping section, the user can define the piping material from the available list of piping material or most common piping material from the drop down menu or a drop down list over here. The user can select any piping material as required. The next is the user can select the piping size or size of the pipe or the nominal size of the pipe from the drop down list provided against the nominal size option. The third option is the piping schedule. The user can select the piping schedule from the given drop down list of piping schedule, and similarly the other information of the pipe length and the elevation and the pump efficiency can be provided in this section, whereas the pipe outlet diameter, pipe roughness and pipe internal diameter will be calculated automatically by selecting any of this option from the drop down list. So the user does not need to provide this information separately. This information will be calculated by simultaneously at the same time immediately when the user select the pipe size and the schedule of the pipe. The next section is the fluid data section, where the user need to provide the physical properties of the fluid. The third section is the calculation section. This is the calculated section where user does not need to provide any information over here. Instead, only one option is provided in this section, which is called as the K factor of fitting requirement. So user can select check or uncheck this option. What happens when you check or uncheck this option is basically, if you check this option, it means that there are you are going to define further pipe fitting components of the piping system, which I will explain in a few seconds. Then the component selection can be checked by this checkbox over here. After that, the user can go to this K factor calculation section of the pipe fitting, where the user can define the complete isometric detail of the piping component, including the elbows and T's and valves and any special fitting which are going to be installed in your piping system. Those information can be selected or provided in this section over here. So the first selection that you can provide here is the K factor calculation method. Three methods are incorporated in the application by the name, and they are Hopper's 2K method, Darby's 3K method, and Crane method. By selecting any of this option, the required or the database of the piping component will be updated in the below section of the components. As you can see, when I select or move my mouse to select different option, the database or the information in the below input section changes at the same time. So once you select any K factor calculation method, it will be selected and highlighted with a yellow background, as you can see. The next section is the friction factor method. Again, the user can select different any given set of equation from the list of equation which are inbuilt into this application from the drop down list for the piping friction method calculation. So by pressing the drop down list, the user can select any equation where the piping friction factor will be calculated. The next section is to define the piping components. So the first section is the 90-degree elbows. So here the user can select the type of the 90-degree elbows by simply selecting the option from the given list of 90-degree elbows from this drop down button over here, and then provide the quantity of the number of 90-degree elbows are present or going to be installed in the piping system. The similar information required to be filled in by the user for the 45-degree elbows, if there are any in your system. Again, by pressing the drop down list over here, you can select an appropriate type of elbow from the list. The similar information can be provided for 180-degree elbow, T's, valves, and any special fittings if there are any installed in your system. Now this is pretty much all the required information need to be filled in by the user for the pipe 1 system or the piping 1 component, whereas the pipe hydraulics, which are shown in the sections of calculation, pipe head loss, and total head loss section for this pipe segment, will be calculated by the application once we run the application. Now once this pipe 1 segment information is provided completely, the user can move to the pipe 2 hydraulic section. In the pipe 2 hydraulic section, once you have already identified which pipe 1 or pipe 2, which pipe will go to what side of the pump, either suction or the discharge, the pipe 2 location will be updated accordingly and will display with the yellow highlight in this page over here. Again, for the pipe 2 hydraulic, the user can specify the piping material, fluid physical properties, and the pipe fittings as described earlier with a similar procedure as for the pipe 1 as already explained. The user can fill in all this information required for the pipe 2. Once all this information or inputs are provided, now the calculations are ready to run, so the user can simply press the calculate button. The calculation will be performed and the results will be displayed in the respective field automatically, and the message bar at the bottom will turn into green color with the caption OK on it, which means that the calculation has been successfully completed. No error messages are found at the moment. Now, looking at the brief of this pipe hydraulic calculation, which were emptied at the start, now you can see the information of the pipe hydraulics are filled in into the respective fields of calculation in the calculation section, piping head loss section, and total head loss section for this pipe segment. And similarly, if I go back to the pipe 1 hydraulic page, where I can also see the calculated results for the pipe hydraulics for this pipe 1 segment in the calculation pipe head loss section and the total head loss section of this pipe 1 segment. Now this hydraulic calculations have already calculated once you press the calculate button. Now moving forward to the main result section. The first result section you can review from the piping system curve tab or a page that is shown or displayed on your screen. Here on this page, the resistance curve or the system resistance curve for the pipe 1 and the pipe 2 has been calculated and projected in the graphical form, as well as in the tabulated form, or the table is presented against each graph with the data of piping resistance curve. Now the next tab is a total dynamic head tab. That's where the complete calculation of the calculation results are displayed for the suction side of the pump and the discharge side of the pump, as well as the total head losses are calculated and presented in the respective field of each section. So the first section over here in the total dynamic head page is the pump status section. That's where it is highlighted that the pipe 1 is installed on the pump suction side and the fittings calculation method was selected as a Hopper's 2K method, and the pipe friction method was selected the equation selected for the pipe friction is the Churchill and Ugassi equation. All this information which you have already selected or provided in the earlier input pages are displayed as a summary over here in this pump status section. The next section here is the result is the suction side head losses section. That's where you can see the pipe 1 was selected to be installed on the pump section, and the pump section side head losses in terms of velocity head, fitting head, frictional head, elevation head, and pressure head losses, and the total losses are calculated and shown or displayed in the respective field against each description. Similar information is calculated for the discharge side head losses and shown and displayed in the respective field. Also, the total head loss or the total system head loss for the similar parameters of velocity head loss, fitting head loss, frictional head loss, elevation head loss, pressure head loss, total dynamic head, total differential pressure on the pump and the total discharge pressure of the pump, the impeller eye pressure, the NPSHA of the pump, which is net positive suction head available at the pump, and the pump required power is also calculated and displayed in the respective field. Moreover, the total system resistance curve of the entire system is also calculated and shown in the tabulated form in the table below in the pump suction or a pump system curve section, and the graphical representation of the total dynamic head of the pump is also shown in the graphical form, with an operating point shown as a little red colored triangle as an operating point is also drawn on the graph over here as shown. And below, the schematic of the entire system and the major calculated results are displayed on each location or a point on the schematic of the pump, where the user can review all the details at the same time. Now again, if the user want to change or update any information in the input pages for the pipe 1 hydraulics and the pipe 2 hydraulics, the user can perform the changes or revise or update the changes as required. And again, by pressing the calculate button, the calculation will refresh and revise all the information based on the new provided input data by the user, and display accordingly in the respective field which I have already explained. Now once the user is comfortable with the calculation, then the user can press the print preview button to project the print preview section or a print preview dialog box to check the results, how it will be printed out in the PDF file or through the paper via printer. Here the total 13 number of pages report will be generated and display over here as you can see on my screen. The user can simply review each page print out to see all the information are displayed correctly on each page, and then later the user can simply go ahead and take the printout into the PDF file or through the printer. So in order to save the results in the PDF file, the user can simply go to the file menu tab and press the save button here, or the same function can be performed on the application by simply pressing the print button over here. Once the print button is pressed, the print dialog box will open where the user can select to print out the results either straight away into the PDF file or through the connected network printer. Once you press the print button on this print dialog box, the results will be immediately printed out and will be shown in the PDF file as you can see on my screen here. The results are printed into the PDF file and are displayed on the file like over here as I can see. Further, the user can review all the results. If the user wanted to change the results or change the inputs, again the user can run the application anytime and generate the new results accordingly. Now this is pretty much the complete overview of all the features and functioning of this application. Thank you very much for your time and patience, and hope you have liked the video. For more videos on my chemical engineering applications, please like and subscribe my channel and visit my website. Until then, take care. Bye bye.